Now let us see the questions for the area under the curve. We'll see the first question with the find the area of the region bounded by the curve y square equal to x and the lines x equal to 1, x equal to 4 and the x-axis. Remember, the full name of this topic is area bounded by the curves. So we'll make the curve graph of all these three functions, and whatever is the common, that area has to be found out. So first of all, we start with the graph. Let's make first of all the graph of y square equal to x. We know it's a parabola with the vertex at 0, 0, and we have taken few points like x equal to 1 makes y equal to plus minus 1, x equal to 4, y is plus minus 2, and hence we have made this graph which is opening on the x-axis, and the graph is there. Now we are left with two more lines. One is x equal to 1, we make that line. We know x equal to 1 is a line which is a parallel to the y-axis. Similarly, x equal to 4 is another line which is a distance of 4 from the y-axis, and we make this line over here in the green line. Now, since the area is from the x-axis, that means it is bounded by the curve y square equal to x and the lines x equal to 1, x equal to 4 and the x-axis. That means of the upper region above the x-axis. So first of all, let's try to find out all the points of intersection. So first point, we try to get the A point, which we get by intersecting the curve x equal to y and y square equal to x. We get 2 points. Second point is C, which is 1, minus 1. Similarly, when we take x equal to 4 value in the curve y square equal to x, we will get the two curves, 2 points, which are B and C, which are 4, 2 and 4, minus 2. We name these points A, B, C, D. Now, the required area is above the x-axis, so we can see the required area. What we have written over here is shown now. That is above x-axis, passing from A to B, from the lines x equal to 4, x equal to 1 and the x-axis. Now we try to find. Now, to finding the area, you very well know the AB is the parabola, and we draw the perpendiculars on the x-axis. That's why in this case we require the area is y dx. If we draw the perpendicular on y-axis, it is x dy, but in this case it is y dx. So from A to B, the area will be y dx, where y square is equal to x. That means y will be root x. So we try to find out the area is y dx from 1 to 4. 1 to 4 is taken from 1 to A point 1 and B point, the x coordinate is 4. Remember, the limit coordinate are the dx ones. That means the x coordinate. For the A point is 1, for the B point is 4. So we take 1 to 4 y dx. As we discussed, y square is equal to x gives you y is equal to root x. So 1 to 4 it is root x dx. We integrate it, place the values over here. We know root x, integral of root x is x to the power 3 by 2 divided by 3 by 2. We place limits 1 to 4. It is 2 by 3. 4 raised to the power 3 by 2 minus 1, which gives you 14 by 3 square units. Remember, if in this particular question we would have got between the curve y square is equal to x, x equal to 1 and x equal to 4, and not written as the x-axis, the last portion is missing, this portion is missing, then we would have got twice of this area, because symmetry is very commonly utilized in areas. If we would have to find the area of AB, DCA, we would have taken the same area and multiplied by 2 without any extra effort. But in this case, since the question was between the curve y square equal to x, x equal to 1, x equal to 4, and the x-axis was specifically stated, so we take the curve above the x-axis only, and hence the area, the answer for this particular question is 14 by 3 square.